Good morning, gentlemen. Apologize for not having made very many videos lately. It's been extremely cold, and I don't heat this part of the old computer shack. At least not very much. So it's been too cold to do much. That's my excuse anyway, and I'm sticking to it. It's not like I've been playing too much Dungeons and Dragons instead of working on old computer projects. But anyway, I finally, after accidentally ordering SOIC components and then reordering DIP components, I finally got some 74 HC14s in here to test the final prototypage of the backplane here. I didn't have any HC14s or HCT14s that weren't in something that I didn't want to desolder them out of, so I had to just order some. I wasn't going to fuck up some of my other stuff, because you know how good I am at fucking stuff up, right? So anyway, here it is. The power circuit works right. If I plug the power in here, you'll see that no, I hate blue LEDs. Just so you know, I'm just trying to use them up on this prototyping shit because I won't go to the trouble of trying to desolder them and save them or anything like that. I got a bunch of blue LEDs in this bulk LED grab bag, and I'm just trying to get rid of them. Anyway, so you can see the 5 volt standby voltage comes up after I plug the power supply in over here, yay. And so we have the ATX power switch connected here. There's also a place to connect the front panel power LED, but I don't have it plugged in at the moment. So if we just push the power switch, you'll see the power comes up after what I've calculated using the 30 frames per second of this video camera. After a quarter second, the power OK signal comes up, and I had to modify the circuit a little bit to make the reset signal persist past power OK. So the reset signal stays low and then holds everything in reset until about 0.15 seconds after power OK comes up. And it's not tied to power OK at all. So like, if you're using a power supply that does this like faster than like 0.4 seconds, you'll have to increase the resistor value here. Anyway, this resistor here is just pulling reset high. That's usually done by the CPU card. That's why I did that bullshit there, because there's no CPU card plugged in. Anyway, so yeah, it seems to work. Then if we just tap the power button, you can see it gives us a nice long clean reset signal there. Reset's active low, of course. And then if we hold in the power button for 1 second, it powers everything down. And then a short press powers it back up and reset sequences like it should, as far as I can tell. I've only checked it a little bit with the camera, but it seems like it always comes up between 4 and 6 frames after power OK. That's at 30 frames per second, so I think we're cool there. I didn't want to drag the scope out and clean up a place for it, because my bench is a disaster area as always. So yeah, that's that. I'm getting ready to see this CPU card is already like obsolete because I already changed it, but I'm going to assemble it anyway and test it just to make sure that some of the stuff that stayed the same doesn't need changed before I get a new batch of boards. And here is the VGA terminal and bus monitor card. However, I decided to split that into 2 different cards because I was having to use too many I/O expanders, and that slows things way down. I wanted to have more pins free on the ESP32 module to connect directly to the bus so that I could generate really fast interrupts when certain bus signals changed, in order to be able to turn on wait really fast, you know, to give the ESP32 time to set up the bus how it wanted to. So there's that. I haven't tested the audio yet. In fact, I haven't tested any of this yet. I soldered it together and then it got super cold, and I haven't been doing much in here since then. So let me see here. Here is the schemataroo for the final version of the backplane. The only things that I've changed really, or I changed a couple of resistor values. Well, these LED footprints were too close together to use. These are 5mm LEDs, and I had to file a little bit of the lip off of the bottom to get them to sit next to each other nicely. So I spread these out a little bit, the LEDs, and I moved the ATX power connector in this way a little more so that this wouldn't be as crunched up against the side of these really small cases. And what else did I do? There was some other little dumb thing that I did. I can't remember what now. Oh yeah, I used the wrong footprints for these 2N7000 MOSFETs down here, so they were really hard to hand solder. I had to change that footprint. I don't know why I did that, but yeah, I had to change the footprint to make those a little easier to solder. But other than that, like the actual like electronics of this prototype actually work right, which is well, I mean, I didn't design this circuit, but you know, it still surprises me when the trash that I lay out actually works sometimes. You know what I'm saying? Anyway, my friend Amardeep designed this like discrete old school logic power sequencing circuit thing here. I was originally doing it with a AT Tiny 85 microcontroller, which was lame because the point of old computing is to do stuff. I mean, even if we're using like a Z180 with giant SRAMs and giant flash ROMs and all this shit, right? Like, the point is to kind of do it like anachronistically a little bit, you know? So like, it's cooler to do stuff without the stupid little microcontrollers that are like 1,000 times more powerful than the host CPU, you know? That's, I mean, sometimes you kind of gotta, like, for that VGA output and stuff like that, there's just not a good way to do that with components that are still available, you know? And that are easy to solder. But like, when possible, I'm not, like, casting shade on the way anybody else chooses to do anything, but I think it's more interesting to do the shit with, like, real, like, as it could have been done back in the day, you know what I'm saying? Although, like, in the way old days, you probably would have had to have used, like, a 4000 series here instead of an HC14. So I'd assembled, my friend Amardeep designed this thing, and I assembled it initially with 74 LS14, and it turns out that the input impedance of that LSTTL logic fucks up the time constants of the RC circuits that are controlling the timing of everything here, which I should have known, but unlike me, Amardeep actually knows what he's doing, so he designed it with HC series logic to begin with, and then I was like, oh, CMOS, I'll use LSTTL logic and be more authentic. Lo and behold, it didn't work. So yeah, for this Schmidt trigger inverter, you have to use CMOS logic of some kind, like an HC14 or an HCT14 would probably work too. But you can't use LSTTL logic. It's got to have super high impedance inputs so it doesn't fuck up these RC time constants. And I have changed this to 330K. Let me fix that before I forget. Originally, it's not Amardeep's fault. He wasn't. He did this on a breadboard, you know, like without an ATX power supply. But originally that was 100K, and the reset signal was deasserting itself before the power OK signal would come up. So I increased that, changed that timing. And I changed this R10 to 1 meg. Originally I had this at 3 megs, so you had to hold the power switch in for 3 seconds to power the thing off, and 3 megs, like, nobody stocks those. Like, 1 meg is like the largest that anybody actually stocks that's like not a psycho like me. So I mean, everything I've got bigger than 1 meg's like half and 1 and 2 watts for old radios anyway, and we don't want to use those big bastards. So at 1 meg, that's 1 second with this particular RC time constant here, so it works fine. So this first RC circuit here provides the delay for the reset. Like, so normally, you know, C5 here charges up through this resistor, and we get this nice like charge curve that goes into the inputs of these Schmidt trigger inverters. And you know, once the threshold on those is reached, they flip high, which will pull the reset signal low through this MOSFET, and Also pull this line low here, and then or pulls it. Yeah, well, it turns it off because this goes low. I'm a dumbass. Sorry. So then when we push the power button, the power switch here, you know, it discharges this capacitor, kapow, and this changes state. And then after you release this, it charges back up through this resistor, but it causes a delay, that RC time constant curve, you know what I'm saying, until these switch, and then reset is released and is pulled high by whatever is pulling it high. Usually the CPU card, but a 10K resistor soldered onto the backplane in this case, since I have no CPU card installed. So, right, so when this goes high, when you press the power switch, it clocks this flip-flop, which is which turns on the power here through this other MOSFET, right? And then normally we'd release it really quick, and none of this stuff would actually do its job, right? So it would stay on, right? And then if we do a short press, this thing does that reset like we talked about before, that nice long clean reset. This debounces the switch here as a side effect of its like RC circuitness, right? But if we hold it in for a certain amount of time, this capacitor will charge up through this resistor and eventually switch this thing. This thing here, I don't know why is there a second one here? I don't remember. I figured this out before making the video, and now I'm drawing a blank. But in any case, after this thing charges up, it'll eventually trigger the reset on the flip-flop up here and turn the power off. And then this diode here just lets this capacitor discharge after the state changes. A little faster so that you don't have to wait for it to bleed off on its own, so that the switch doesn't get, like the time constants don't get fucked up when you switch things on and off really fast, you know what I'm saying? So, it works pretty good. I head scratched trying to do something similar for a little while, and I'm just too dumb to do this kind of stuff, so he was like, oh, that sounds like an interesting project, let me give it a crack. I'm like, he did it in like 2 minutes or something like that, because I'm a dumbass. But anyway, that's the backplane. I've got 4 more of these prototype router boards that basically work but have like different component placement. It's really hard to solder these MOSFETs down here. I don't want to give them to anybody because they're too hard to, I mean, I don't want to try to, you know what I'm saying, like they're too hard to like expect people to like not think are junk. So I think I'm gonna like grind my name off of the ones that I've got left and give them away at the next Tandy assembly auction or something like that. Maybe somebody else can like not use the power sequencing stuff, since the MOSFETs are so hard to solder, and just like turn the thing on and off manually with a toggle switch and build their own nice little RC bus machines. Yay! Okay, so that's that. Alright, bye.